Hello, welcome back. This is episode 21 of building a 2D game in Flutter. However, in the last episode and in this episode, we are not even looking at Flutter at all at this point because we are trying to figure out how can we communicate server client in order to make this really multiplayer. How can we basically send messages back and forth? Mainly, the client will send updates to like what did the player do? Did the player shoot, or did the player move? Did the player rotate? Things like that. And the server will then basically update the game state and will send back the game state to the clients. And so basically, just to be clear, the client will most likely not even send any positions or any of that sort. It will basically just send key presses, right? So if the client pressed a key, something happens. So we can't have cheaters. So we can't say, oh yeah, my player moved here, right? And it's not even possible. And then we can just move behind another player and do that player damage or something, right? So we want to prevent cheating, even though probably in our little game it's not that important. But since we're trying to just do that to see how things would work, we try to do things correctly as it would be done in a, let's say, larger scale game as well. So what we did so far in the last episode, we created a proto file here, which kind of defines our service that we're using, and for now we're just sending press keys, and basically this will just be any key, it doesn't matter, and then we'll just every time we send any key, we'll just create bullets for now, and then we'll send back to the client how many bullets are in this game at this point. This is just to have a short little spike to understand how things work. Obviously, one thing I'm realizing is that the generated code, right, since we are inheriting from it, as you can see, the server here is inheriting from this base class. We have to be really careful about how we name our services, right? Because most likely, well, I mean, we can always change it. Not such a huge deal, but definitely those that will change the way the code is generated. So we have game updates, we have client update, and the game updates come from the server in the stream, and the client updates are coming from the client, basically the input. And we call this communicate because we are just bad with names. I'm not sure what I would call this. We called the whole thing also message bus because it is kind of a message bus between client and server. Maybe we'll come up with better names in the future. So now we need to generate the server. We already started doing this here. So let's just say we have our server. Let's look at the code here. And actually we might. Yeah, let's say this one because this is using streams, so we might actually. It might actually be really useful to have that. So basically, game server, and then the game server extends another server, and like, what can it extend? It extends the game update services base. Okay, and now we can see that got now imported from the generated code. And now we're getting already a warning that we're missing an override. And now we have that override. So let's move that over here a little bit. So we can see here now what's coming in. So we're getting a client update stream, and it's expecting us to send game update messages. Okay, so that should be easy enough to do. Every time we get a request, we will basically update the number of bullets. So let's just put a number of bullets in here, in bullets. So that will be our game state, right, for now. Let's just do this. We created another class here called game state. Again, we're gonna be really dirty here, doing this as quickly as possible. This is just a prototype. We just try to see how this could work in our game. All right, and then can't be final because we're going to keep increasing this, and also it will just be null. So we actually don't need a constructor at all, and we'll just directly on the game state will increase things. So we have a game state in the server, okay, and and we create it immediately. So now we have our game state. Now every time we process a request, we basically will update our game state. So let's look at how this is done in the chat, in the route chat. We had this nice little way of iterating through a stream, right? So basically we are iterating through basically the messages like this. Like the messages are not there yet, but we are kind of iterating as if they're already there. So this will be it will basically be a request, but what's the request? It's an update, right? So we call it client update in request. So it's kind of confusing that the request is actually called request. We could call it update events, because that's what they really are. Obviously, we do also need to do this because the server will return. It will basically yield values out, and that will then be converted into a stream. Okay, so now what we'll do when we get a client update, it will have a pressed keys. It will have a pressed keys, but we want to actually get the pressed keys. So that's kind of odd. So how do we get the pressed keys? So that's a little bit confusing. So what is this pressed keys? What is this in thing? What is this in thing? Get pressed keys. So it's getting us back in. Oh, maybe we can just do this. Maybe it's just confusing the way this is shown to us. I'm not sure. So what I want to do is basically what I want to do is I want to say game state dot end bullets, right? So for now, let's just make it simple. Every time we get an event, we just increase it. Why doesn't it allow us to do that? Is this not existing in Dart? Oh, we're missing a semicolon. Okay, so we're increasing the bullets every time we get a request back from the client. And then what we'll do, we need to, and then we basically just yield the game state. But we need to make it a game update, right? So the game update is something that we defined, that is part of the protobuf. So the game update has basically it has end bullets, right? So we could also, instead of making this a game state, we could call this game update. But you know what? We'll leave it like this because in a real scenario, we most likely won't store the game state in the exact same format that we are going to send it out. That might not be working very well. So what we're going to do is we're going to create a game update. And then we'll say the end bullets equals our game state and bullets. Okay. And sorry for hitting the microphone once in a while. But okay. So this should actually work. We're just not using CU. Okay. That's fine. We don't need to use it right now. Let's indicate that we're not using it yet. And this should actually be fine for the server. Let's actually see if we can run this. The server already. Well, actually we need to make it listen somewhere, right? So it's running. Let's see. Can we run this? Can't run it. We need mainly a main. No. Well, we'll run. Okay, so we can see that they have in the build folder they have a way to run the server, but let's just make sure that. So we need this, right? What is this? Oh, so this is a service. Okay, so let's rename this a service as well for now. Just to basically, I'm trying to not deviate too much from the example that we have here in order to not confuse us more than we need to. So then we have a server. We're gonna just copy that code over here. So you have a server, and then gRPC server. Okay, so that's something we probably need to do, but basically we need to give it the game service. So we have a server and a service. Okay, that makes sense. And then the gRPC, where is it coming from? gRPC here. Oh, basically it's being implemented. Okay, so what? Maybe we'll just do this and then. Okay, so yeah, it's this server. So we call this game server, right? And then maybe this will be and then we import. And what we'll do, we'll add a show in order to. I want to kind of see what we're kind of getting from everywhere. So here we kind of see all these things that we're getting from the generated code. And okay, so that's nice. I like that. Now we are basically creating a gRPC server, and we are listening on it. Okay, and so all we need to do now, actually, we don't need to have a separate file for this. We just basically say, here's our main file, just run me. Okay, well, needs to be a future. Okay, it needs to be a game server. Okay, cool. So now we should be able to run this. Okay, cool. Failure to create server, address already in use. That's most likely because we're still running this server over here. Okay, now let's try this again. Okay, cool. So we got our server is listening. Okay, that's awesome. Now basically all we need to do is create the client, right? And we're basically going to also look here how we would go about that. So let's make a new file here called client. And so the client, I guess it will also be, it will just be a service, right? So we have, let's do that. We have the client. But the thing is, a client needs to. Okay, so the client does not extend anything. Instead, the client just somehow knows where to call. So let's look at the chat one. Where is the chat one here? Okay, so here we have this. Run route chat. I wonder where it's calling into the. Oh, here we go. So the main important part here is, so basically, what we're gonna have something like we're gonna have something like on key pressed, right? I mean, you're not even gonna worry what the key is at this point. We'll just make up some integer. It's not important for now. But basically, let's just say that the space key, final space key equals 0x1 for now, right? And so what we can do is first of all, we want to call to the server. So we have the stub, and the stub is basically, where is this created? Okay, so we have the route guide client stub. Okay, so that needs to be something that comes from the generated thing. So actually, so our client is called different. We call this client update, right? So most likely there should be something like client update. Yes. So we get the client update. That's our stub. I want this to be final, and then here you can kind of see like the main. So we're using main here. We're using main to set this up because it's async. We cannot have a constructor that's async, right? and I probably like I'm gonna go to the server right now, and actually I don't like that it's called main. What we're basically doing is, well, I mean we're creating it. It's called init. At the very least, we are knitting a game server, right? And so here we're gonna have the same method here. We're gonna actually copy that, but not the entire thing. I want to copy this bit by bit. So it's gonna be init, and since we are creating the stub inside init, it can't be final either. Okay, so we got init, and so what we need to do here, and this is where this gets really verbose. So let's do this. Okay, move this a little closer, or maybe move this to middle. So basically, we create a channel, so we need that as well. And I think the client channel comes from the gRPC package, yes, or it could come from the service API. But I think it needs to come from the gRPC package. Most likely, let's put a show here. Most likely this is in the service API anyway. So let's look at that actually. Where are we here? We are inside gRPC. So we are not in the service API. So it's a good thing that we imported it from there. So we got our channel. And so first of all, we create the channel. And that's a client channel. I'm going to put localhost. I'm going to see if that works. They have over here another way of saying localhost in a very elaborate way. The port is basically 8080 like we have on the server. Okay, now we have some interesting things. We have some options. Okay, and so in these options, so first of all we need to make this an equal, and we need to spell things correctly. So okay, the options. Oh, okay. So it's not like an options like I was thinking. It's actually let's create the options separately. So final ops equals. We create a channel option. Channel options. Okay. And so there are different things we can give it. So for instance, we can say that the credentials are channel credentials insecure. So we don't have to give it like some creds file. And so there are other things that we could have got. There's a backup strategy. That's interesting. A connection timeout, idle timeout. Okay, so we could even say like what are we going to say, what we are, what user agent, and so on. So that's interesting. So we're going to use the ops here. So now we should be good for that. We have the channel set up. Okay, so in this case here now, it is basically running. So what we actually need to do, we need to have something running that's like a timeout that keeps pressing keys randomly. Like basically simulating that the player is pressing keys. So basically void setup well, simulate key presses, right? And so what we'll do is we need something to occur multiple times, kind of like a set interval, a sect, and Dart. And that's exactly what I'm going to do. Google in Dart. How do you do that? Well, this is window. We don't have a window. What we may have to do is we just create a future, and then every time this is like a similar thing that we did in the in our game actually, where in order to keep the game loop running, we basically basically kept setting the interval over and over. So this is kind of setting like a timeout, right? So future late, we give it, let's just say 200 milliseconds, right? Actually, we don't need these. Well, we could keep the cons. It doesn't hurt that we remove them, and they're kind of looking, make the code less readable. So basically, what we want to do, simulate key presses, and then basically say on key pressed, right? And so and on key press, then we simulate key presses, right? Or actually now then we say schedule key press. So the thing is obviously that this will fire every 200 milliseconds constantly. That is fine, but we can basically make that more random if you wanted to. But fine. So now on key pressed, that's when we basically want to send the server a message. However, we want to keep the we want to keep the we want to keep the channel open the whole time. We don't want to like how do I say this? So basically in this chat thing here, where's this one chat? One chat. Run route chat, right? In this method here, we don't necessarily want to basically get stuck in this node here, in this one here. Well, actually, so okay, this is actually what we want. So what we want to do is we're going to say listen to game updates. And then we just copy this info here now. So basically the stub, this is going to be, so that's kind of what I'm saying. So we need to actually create a stream. We need to create a stream of key presses that then we modify in a different place. But that's fine, we'll do this step by step. So is this press keys? Okay, maybe. So we need a stream of press keys, I think. I'm trying to figure out what the... This is an int. Let's look at our prototype and for our protobuf here, and let's see. Communicate. That's what we actually want. We don't want press keys. We want communicate. Okay. Make that a little bigger. Let's see if we should have a communicate function on there. Otherwise, I don't know how this would work. There's no communicate. Okay, let's look here then. In this proto, they called it route chat, right? And then they have a route chat on the, maybe. So this is a service. I don't think they're defining the route chat in more than one place. Yeah, they only define it inside the service. So this is our game updates service, and it has a communicate method. So we should have a communicate method generated, right? Let's actually look through the generated code. There's a communicate method, okay? And it should also exist on the client. Yeah, so there you go. There's a communicate, and you can kind of see that should be like some sort of a stream. And it has a response stream of game updates. So that's kind of exactly what you're looking for. So what I don't understand is maybe it's just because I haven't. Okay, so let's just get rid of this code that doesn't work. Obviously, it's not a route node. It's going to be a game update. So why is this not existing? Client update. Oh, maybe. Yes, maybe we didn't call it client update is. No, client update is a message type. Okay. Okay, so we typed that stub wrong. So let's look at how a stub is typed in this one here. So we have the stub, and that's a route guide client. So in our case, it would be something like a game updates client, I guess. Game updates. Okay, cool. So that's it. So we did that wrong. And now we got communicate, and we need to give it a stream though. So if you look at this method, it takes a stream of requests. So what we're going to do for now, we're going to create this. So we need to somehow pass in a stream of requests. Stream of client update. And then basically that would be the CUs, client updates. And so we should be able to pass those in. We should be fine. All right. Yeah, it's telling us to omit the type annotations. That's fine. Okay, so that's fine. So we basically need to tell to listen to game updates. We need to somehow create that stream. And so we most likely will need a stream controller to do that. By the way, I said that basically we don't want to use any libraries in our game, and that is true, but only for the client side, right? So obviously we do not, under any circumstances for our little game, want to go ahead and try to re-implement something that gRPC does. And if we have a bunch of streaming like this going on, if it gets wieldy, I will actually pull in Rx. But for now, we're probably fine with a simple stream controller. So that's that. And actually, we could create a method that gives us a stream like that, where we're just yielding every so often. So we might actually do that. So now we have to listen to game. We have the call, and we basically just want to listen to that. Let's go back to our chat thing. Right here. Am I already here? Okay, yeah. So basically, in our chat, we had the outgoing nodes. Those were basically. So here, sorry, this is the response from the server. So basically, what we can do is for, and we have to put the await here, which then means we have to put an async, but we'll do that in a second. So for final, there will be a game update. So it's called GU, right? In this call, and so we name them game updates. Game updates. And so actually what I do is I say this is a stream. So let's start with this because this is a convention that I've been using, which works really well because you see immediately what are values, what are kind of lists, and what are streams. So we got you in game update. So you dot okay and bullets, right? So then we basically say we print a game now has so many bullets. All right. So that's our client. And all we need to do now is we need to also pass in a stream of updates. And they did this really nicely here. They basically just create a node. And then they converted this node into, they're just basically piping this node, but delayed, and then it becomes a yield, and then becomes a stream that way. So what we'll do is we'll also create some sort of stream of well, so we have a so we have a key press. So that's kind of like how we do this on key press, right? So this is not going to work at all, right? So because if we actually have to push into some sort of a stream controller. So let's say stream controller, and that's going to be of, let's say int, say pressed keys, right? So we'll we use that, and that's basically a subject, so to speak, and then we'll push into that. So when we have a key press, we'll just, for now, we always press put the space key in there, and then when we listen to game updates, we basically will listen to these press keys. What is it complaining here? Oh, we need to make an async. We need to make this async. And then we can say, listen to game updates. And we need to give it this. But the client update is basically nothing else but these press keys converted into client updates, right? So what we can do is we can say final client update stream is basically press keys, and we'll map them. Let's say, I think we need to say stream. Can we map? Okay. So then we map them to client update. Okay, and then we create that method. Add a return type. Why can't we have a return type? So this is our event, this is our thing, and basically what we want to do is we want to return a client update. And with the press keys equals the press key. So it's called event now. Let's rename it press key. So and then what this returns is a client update, and I want to annotate that even if sometimes you don't have to at least. Okay, so now we got that going on. So we got the client update stream, and now basically we can say listen to game updates, and we give it the client update stream, and everything should be happy. Okay, cool. So we got the. So let's look through this again. So we basically create our channel. Only thing is, like, where are we using that channel? We still need to hook that up, obviously, but we are basically creating the client updates from the press keys. Put them in here, and the press keys. So first of all, we need to create that also. Is a let's make this final. Okay, so we have a stream controller here, and so we pass it in, and so now basically we have the server and client communication going on, right? The press keys are basically sent every 200 milliseconds, and basically that's when we add. Obviously we have to await that though. Oh, we have on key press, so this is actually here we have to actually do that. So we on key press, we put that here, and this is just a mapping function to convert this to client update. So we see the patterns, right? We're gonna have data on the client and server, and whenever we need to communicate, we use these generated classes, right? They are generated in order to do that. So so that's interesting. Now all we have to do is do the last bit where we have to do something with this channel, obviously. Oh, we already passing. Oh, I'm confused. So this is a channel. Oh yeah, we still need to create our stub. We're not creating that stub yet. So we need to say our stub is the game updates client, and we need to pass our channel. And then there are other options. So let's just call those channel options. And then we have more options, which are going to be the client, or let's just call them the stub. So why is this called stub? Because it basically looks like it looks basically like we are calling this method directly, right? When we call stub.communicate, it looks like we're actually calling a method directly in the client, right? But it's actually just like a stand-in. It's like a stub for the actual server. And it handles under the hood all the communication to the server. So that's why it's called a stub. But we could actually also say, well, it's kind of weird. There's called, I want to call this client. So the client communicates, right? And in a way, we're calling a method on the server, so you might also even call it server, but then this is called client. So this is because I think we call client update, yeah. So we'll see how we call this in the real once we implement this for real. So the options are basically call options, and they are and you can basically give a timeout. Okay, that's interesting. So we can basically every time we call, I guess. So they're using seconds here of 30. 30, fine. That should make us happy. And then basically you can give this as the option. Stub client ops. And now we can actually name this client ops, right? Because now we named this client. So we can say client ops. Right, but this basically happens. We could also call this call ops, I suppose. So this is like for the channel itself, and this is for the whenever we make a call. Like how long are we going to wait for a call until we say it's timed out, for instance. There are obviously probably more call options that we can set. Okay, it's actually a map. We can have more. Oh, we can have metadata. Okay. Well, we're not going to look into that in too much detail at this point. So the thing is, they are basically saying, since we are scheduling a timeout, our client should actually stay alive. It should not quit. So here, basically, what we're doing here is we're just basically running all these methods, waiting until they're finished, and then we basically go ahead and close the channel. We will never do that. Our clients will basically stay on the whole time, right? So let's just quit everything and let's just run the server again and the client. I want to kind of see what happens. So we don't have a run client yet. So we need a main. Okay. So let's do that. So client main. Basically that. So let's put that in here. And it's going to be in it. And the thing is, we don't pass any args really, even though it has. So I think it still has these args. Yeah, that's fine. Doesn't do any bad. So now let's try to. So we're going to rerun the server. And then we're going to run the client. So we still need to actually run that. Okay. So nothing is happening. All right. Let's see. Why do we have this bin? We don't need this bin. We can remove that. So why don't we deadline exceeded? So somehow we didn't. We're going to say got key, and we're going to print this out. All right. And so now we're using it, so we might as well name it like that. So somehow we didn't really connect right. So we got the server initialized, and then we basically have the client connecting and it's not doing anything for real. So so let's go to the client. So we're giving it the stream, right? But we're never scheduling. Are we ever scheduling the key press? I don't think we are. Yeah, so we never get a message from the client, right? So let's see if that's maybe the problem. The other option, obviously, is that this local host thing doesn't work. So, but I don't want to assume that yet. So let's rerun the server, and let's rerun the client. Okay, yeah, there you go. It's working. So we got the spacebar key basically, right? We got this, and then we got the server keeps sending us back the information. Okay, so I would say that this spike is now working, and it keeps going. So let's see. Let's make sure that it can run for a little bit. Okay, so that's what I wanted to see. What does that mean? Deadline exceeded. For what? So what are deadlines? Let's put why we recommend being deliberate about setting deadlines. Obviously, they don't have it in Dart. So what's the context? So somehow, I mean, maybe the deadline is like until we have. Maybe it's like preventing the client to be flooded with messages from the server and vice versa. But the error happened in the client. The server is still happy. So actually, if we rerun the client now, if you can see that the state was kept on the server, and basically it keeps working, and the client now keeps getting updated until there's. We can see that this is about after X amount of messages when X amount of time passed. So we need to maybe. So we have. Oh, maybe this is the. Maybe it has to do with this timeout. So let's just set this timeout really small, and then it should basically bomb immediately. So let's do this again. Okay, so that's why. Because we define a timeout here. So let's read a little bit about that. The timeout. Set the timeout and configure. So if what happens if we set no timeout? So if the timeout is null, it never sets the timeout timer. See that? So what we'll do, we'll deliberately set it null. And now we should be actually fine. And we see here something interesting. The way these comes in, right? We have a constant thing. I don't know if this is anything that's just maybe how this prints out in the terminal, but those are things that we're gonna have to look at closely. Okay, but basically, we now have a client channel that never closes. Obviously, like in the real game, we'll have to basically figure out reconnects, like what if the client disconnects and all these things. But for now, we have some sort of working example. And I think this is a good place to stop. So I will, again, as I said, I will take short breaks in between. Basically, anytime we achieve something, roughly in an hour, every hour I take a short 5-minute break. So I will take a short 5-minute break, and what we'll do next is we will look at how can we model our basically our game model, no pun intended, how can we model that into protobuf things, and what kind of things do we maybe have to change? So we'll look at that, and we'll keep working in the spike, because that's just much faster to get feedback. We don't want to add anything to the game yet until we kind of have this figured out. So that's what a spike is for. You kind of spike everything out, and once you feel like you kind of know how this should be done, that's when you basically start implementing it into the real app. So that's what we're going to next. First, figure out our proto buff types. So thank you for watching.